Assalamualaikum. I am Nick Ashraf bin Yusuf. So I'll begin by doing the demo and the explanation for the task 3. That is first to analyze the malware.vmem, which contains a memory dump of a system that is infected with the malware. So before we begin with the setups, we have to make sure that the vmem files is downloaded, and it has to be in this exact directory file which I'm showing here. This inside this volatility file and alongside with other files. So this is a major step. It has to be in this exact directory, and then we can go ahead and put on the command prompt. Okay, and now I'm in the correct directory, and now I will paste the specific script line to see if the volatility tools is actually properly working and is running. So I have the script here. I will just copy this and paste it, and now we wait a few seconds, and now as you can see, everything is working fine. The fine and the volatility program is running and working, and then I can go ahead and test the next task with this coding line. Just copy this and paste it in the same command prompt with the same directory. Wait a few seconds. So as you can see, the second command line completes our first task. That is, it gives us the information of the machine operating system, including version and architecture type, and alongside from this we analyze the malware.vmem. I will show you the code again, and here are the info and the statistic that it provides us.
Thank you very much, Mr. Ni'ama, and Assalamualaikum. My name is Muhammad Haris bin Ilmi. I will be continuing the task for the task 3. So, continuing from Ni'ama's work, upon completing this command, the -f malware.vmem image info, we are able to receive the machine operating system information, including the version and architecture type. So as you can see here, the suggested profiles, the scan revealed that the system profile is WinXP SP2X86, and this proves that the infected machine was running on Windows XP as well as a 32-bit architecture. So this profile will be used as a decryption key for the next steps for this task. Okay, after completing that task, we are going to continue to find the infected process. So by that, we are going to use this command, which is the ps3 command. So we are going to copy it and run it. So from here, we can see all the files that is within this malware.vmem. So what we are looking for here is essentially any unusual process, any unusual parent-child process that is running essentially. So how we are going to find this is a great starting point is to look at the parent-child relationship of the processes that were running when the memory was dumped. Malware often hides by spawning from unusual parent processes from a basic Windows service.
So I will continue the next part. So because the malware is designed to hide, looking on the process tree is not enough. So we need to run the connection scan command to search the memory for active or recently terminated TCP network connection. So we run the connection scan command. So this is the connection scan command, and then it will show the local address and remote address. So we can see that this is the port 8080 and it connect with the foreign IP address. So we see this is the suspicious on this IP address, and then we see the process ID is 1484, which is it same with the explorer.exe. So we suspicious the malware is in the explorer.exe. So after that, because we want to target the explorer.exe process ID, so we run the command malfind and the process ID. So this is the command malfind. So after we run the command, we can see the specifically hunt for hidden injected code that does not belong is in process normal memory space. So we can see the output show the page execute rewrite, which is it show highly abnormal and indicate memory allocated specifically for running unauthorized code. So the next we see the hex dump started with 4D 5A in the MZ header. So this is proof the entire hidden Windows executable exe file had been injected directly into the memory space of explorer.exe file to bypass antivirus detection. So that's all for the task 3, and we have been completed for this task.
To summarize our findings for task 3, the infected machine was running Windows XP 32-bit from the memory analysis. The main suspicious process was identified as explorer.exe with PID 1484. The evidence suggests that the malware compromises the system by injecting executable code directly into the memory of explorer.exe. This is supported by the malfind result, which showed executable memory protection and an MZ header inside the process memory. This type of behavior is commonly linked to process injection where malware hides inside a legitimate Windows process to avoid basic detection. From that compromised process, the malware showed suspicious external communication through port 8080. The consequent result linked PID 1484 to two remote address for 1.168.5.140.8080 and the other one is 125.19.103.198.8080. This indicates possible command and control communication where the infected system may be communicating with remote attacker controller server. By combining the result from image info, PS3, consequent, and malfind, we were able to map the malware activity from the raw memory dump image info, confirmed the operation system profile. PS3 identified the suspicious process, consequent revealed the external network connection, and malfind showed sign of injection executable code. Overall, our task 3 finding is that the malware most likely used process injections inside explorer.exe and then use that process to communicate with external remote server over port 8080. So thank you for watching our demonstration.